Welcome to today's episode. We're diving into the intriguing world of distributed systems and the challenges that arise from failures within them. As technology advances, it becomes increasingly important to understand not just how these systems can fail, but also how we can effectively mitigate those failures. Throughout our conversation, we'll touch on concepts like Byzantine fault tolerance, redundancy, and the unique difficulties that come with operating in a distributed environment. So let's jump right in. Failures in distributed systems can stem from a variety of sources. These might include software bugs or even discrepancies between different versions of an algorithm running on various processes. When all processes are using the same version, identifying and addressing failures can be relatively simple. But things get trickier when some processes are not fully controlled and may even mislead others intentionally. This scenario underscores the need for robust fault tolerance mechanisms that can handle such complexities. Now let's talk about Byzantine fault tolerance. This concept is particularly important in fields like aerospace, where reliability is non-negotiable. In systems like airplanes or spacecraft, components don't just take responses at face value. They cross-validate results to ensure they're accurate. This principle also plays a critical role in the world of cryptocurrencies, where there's no central authority overseeing transactions. In this decentralized space, malicious participants might try to manipulate the system by feeding false information. That's where Byzantine fault tolerance comes in, helping to maintain the integrity of the system despite these adversarial attempts. To tackle failures effectively, one common strategy involves creating process groups and introducing redundancy within algorithms. By building in redundancy, systems can effectively mask failures. For example, if one process goes down, users may not even notice because other processes continue to operate seamlessly. However, this redundancy can come with a performance trade-off. When everything is running smoothly, processes need to be responsive. But if a failure happens, the system might have to slow down to handle error correction. On a preventative note, there are several best practices we can implement at the software level to avoid many failures in the first place. This includes thorough code reviews, extensive testing, and ensuring message delivery through timeouts and retries. It's also crucial to maintain the correct order of execution for local steps. Most of the algorithms we'll discuss later assume a crash failure model, which allows for the introduction of redundancy. This not only boosts performance, but also simplifies both the implementation and understanding of these algorithms. Throughout this episode, we've introduced some key terminology related to distributed systems and the challenges posed by unreliable components. These challenges can manifest as message delivery failures, process crashes, or even network partitions. Grasping this terminology is essential as we continue our exploration of the solutions that can be employed in distributed systems. As we move forward in this series, we'll revisit the potential pitfalls that distributed systems face and examine the various strategies available to overcome these challenges. The solutions we discuss will be grounded in the concepts we've covered today, providing a solid framework for building more resilient systems. For those eager to deepen their understanding of distributed systems, there are several fantastic resources available. A couple of notable texts include Distributed Systems, Principles and Paradigms by Tannenbaum and Van Steen, which offers a thorough overview of the principles behind distributed systems, and Distributed Algorithms by Lynch, which dives into the algorithms that form the backbone of distributed computing. Another great read is Introduction to Reliable and Secure Distributed Programming by Kachin, Gueraoui, and Rodrigues, focusing on how to create reliable and secure distributed applications. These resources will certainly enhance your grasp of the complexities involved in distributed systems. To wrap things up, understanding failures in distributed systems is crucial for anyone working in technology today. By recognizing the different types of failures, implementing strategies like redundancy, and utilizing concepts such as Byzantine fault tolerance, we can create more reliable systems. As we continue this series, we'll explore the solutions that can help us navigate the challenges of distributed environments. Thank you for joining us today. And we look forward to our next discussion on this fascinating topic.